let's start new chapter, which is chapter number 2, polynomials. Right? This is very interesting chapter, and this chapter is going to come again in grade 10 as well. So focus on this chapter, it's easy as well, and some concepts are being repeated in the next year. So first of all, let's start what polynomial is. Before we move on to the polynomial, let's recall the knowledge of algebraic expression that you learned in grade 8. Algebraic expression. We were discussing about 2-3 terms, very important. First, let's start with the constant. Now, constant means what? Whose value is not being changed, right? It is going to stay as it is, not going to change. In this simple term, not going to change. Let's say, if I say a number, let's say 4 is a number, that is going to remain 4 forever, right? It's not going to change, right? So this kind of things are called as constant. 4, 3, 2, negative number also you can take fractions as well and decimals as well. Now come to the variable. Now meaning of the word variable with this, as we discussed, variable means what? Varying, changing, means which can change. Variable, right? Changeable. So we are denoting variables as the alphabet in small letters, right? So in our case, let's take X. X is the alphabet. Now next, coefficient. Now this is very interesting. You need to understand the difference between constant and coefficient. Students are still confused between them. Let's say I take one term. So I take one term, let's say minus 5x square. Here x is the variable like we discussed here. Minus 5 is not constant here, but it is coefficient because that number and the variable is in product. In that case, this number is called as coefficient of x square, right? Wherever there is variable, there always will be coefficient, right? And if there is no variable, then there will be constant. There is no variable over here, so it is called as constant. But here there is variable as well as the number. So this number is called as the what? Coefficient. So these are the 3 very important words that we need to remember. Now one more word that we need to discuss, that is term. Term means what? If you take any number, right, that is term. If you take only variable, that is also term. If you take coefficient and the variable, that is also term. So this all 3 I can take as the term. Now how terms are being differentiated? They are differentiated based on the operators. In mathematics, there are 4 operators, right? Plus, minus, multiplication and division. Now, if we want to separate 2 terms, if we want to separate the terms, we are only going to use these 2 operators, that is plus and minus. So, if I want to make an expression, I will be using this 1, 2 and 3 terms and any of the operator. So let's make an algebraic expression. So first of all, let's write 4, then let's take operator plus, then x here, then let's take operator, okay, here minus is there, so let's keep minus 5x square. So you can see over here that I have how many terms? 1, 2 and 3 terms, and the operator, they are connected by operator, that is plus here, and in this case minus is the operator. Now remember, if you take multiplication and division as the operator, okay, it will be considered as one whole term, right? We'll discuss in later. So this first term, second term, third term, and there are 2 operators. So this is the algebraic expression that we discussed in grade 8, right? You can arrange in the manner that x square come first and 4 constant goes last. That's the generally standard form we remember. Okay, so this is about the algebraic expression. Now why are we discussing algebraic expression in the chapter of polynomials? Because they both are connected, right? Now when we talk about the algebraic expression, an algebraic expression will be only said as polynomial when it has the non-negative power, non-negative integer power. Remember, very important condition, we should be having non-negative integer power, then only we can say that non-negative integer power, then only we can say that algebraic expression is what? Polynomial, right? So this is the how we differentiate between polynomials and algebraic expression. So this is the condition to be a polynomial, right? Let's give a title, polynomial. So polynomial. Okay, now what's the condition? Non-negative integer power. Let's write few algebraic expression and decide that it is polynomial or not. So first of all, let's take that only, that minus 5x square, then plus x plus 4. Now see over here, first of all, we need to see about the power of variable and nothing else. Only need to focus on the power of the variable 2. Is it non-negative positive? Non-negative integer? Yes, right? This is also, if there is no power, we consider as 1. Remember, we learn in the chapter number 1, number system. So this is non-negative integer. So it is polynomial. Very simple to do, right? Let's see one more example here. So let's talk about 5x raised to 1 by 2 plus x cube. Okay, this is interesting case. So come to the power of the variable. Here power is 1 by 2 and here power is 3. This is non-negative integer, right? So this is accepted. But 1 by 2, is it integer? No. 1 by 2 is the rational number. But what do we want? We only want integer as the power. So this is not polynomial. Remember, 1 by 2 power is not accepted, right? Because it is rational number. Okay, let's talk about one more case. We take, okay, let's say 6x raised to minus 2 plus here 3x. Okay, now let's talk about the powers again. Here power is 1, so that is accepted, non-negative integer. But here minus 2, is it non-negative? No, it is negative. So this cannot be a polynomial. So this is also not accepted. Let's discuss one more case. Let's say 1 upon x plus x square. So this is very interesting. Okay, power of x. Now see over here, it is 1 only. But okay, let's continue though. Here power is 2. This is non-negative integer, accepted. 1 upon x. Now see, this is also not accepted. You must be thinking that 1 is there in the positive power, right? So, but if you write in the numerator, that will be x raised to minus 1 plus x square. Now, what power are we getting it, right? We are getting non-negative power. We are getting negative power. But what do we want? Non-negative integer. So this is also not accepted. So we always need to remember one very important condition, non-negative integer power, right? If it is being followed, then it will be polynomial, otherwise it will not be. Now let's discuss few questions based on the identification of polynomials. Now let's discuss examples. Which of the following is polynomial and which of the following is not? Let's start. First of all, it is written 9 over there. Is it polynomial? Now see, polynomial means what? You take the variable, and if variable is having any non-negative integer, then it is not. Otherwise, it is polynomial. Now see, there is no variable over here, right? So we don't have any problem. So it is no, any chance to get the negative or like fractional powers of the variable. So we will consider this as the polynomial. Remember, why are we considering polynomial? Because here there is no variable, and to be not polynomial, right, we should be having negative power, right? We don't have anything like this over here. So it is polynomial. Let's discuss the second one. Root 3 x square minus 2x. Again, ignore everything else and focus on the power of the variable. Here it is 2, okay, integer and positive as well. Here nothing means we can consider as 1, right? So it is positive and integer as well. So it is polynomial. Now come to the next one, 1 minus square root of 5x. Now x is under the square root. Now we learn in the chapter number 1, if something is under the square root, then we can write it as x raised to 1 by 2, right? Now this is not what we are expecting as the polynomial, because this is non-integer number. This is not integer, right? This is fraction, not accepted. So this is not polynomial. Come to this question, 1 by 5 x raised to minus 2 plus 5x plus 7. So is it polynomial? We discussed just one question that x was in denominator and we said it is not polynomial. Now see, try to keep this x into numerator, right? So if we try to do that, let's see how it is working out. So 1 by 5 x raised to minus 2. Okay, let's keep 5 in the denominator and x into numerator. So if we are keeping this x into numerator, sign of the power will be changed. This negative will become what? Positive. So x raised to 2 over 5. Now see, this is becoming as the positive power, right? So no problem over here. Remember, you need to simplify sometimes as well. That is it working out as the polynomial or not. Don't keep it as a straight manner. If you can simplify, try to do that. Now see, this term, there is no problem. 1 is the power. This is constant. We don't bother about that. So this is x squared by 5, then 5x plus 7, right? So this is can be considered as the polynomial. And the last one, 1 by x plus 1. Now guess what here? Is this polynomial or not? Right? This is very evident that this is not polynomial. The case that we discussed previously, it is something like that, 1 upon x. And if we try to simplify, I think it's not possible. Negative power will surely come into picture, right? So this is how we identify that given question is